Welcome to SOS video on linear inequalities. So our main concept is that linear inequalities in two variables can be graphed on a coordinate plane. Remember that an inequality shows an unequal relationship, and we are going to be using either the less than symbol, greater than symbol, less than or equal to, or greater than equal to. And after we graph the inequality, we're going to use a test point, which is an ordered pair that when I substitute it in the inequality, it will tell me if I graphed that correctly. All right, so we're going to be graphing linear inequalities. First step you're going to do is make sure the equation is in y equals mx plus b form. If it's not, you need to rewrite it. Second, you're going to graph the points of the boundary line as if it were a linear equation. Show what method you used. So you might use table of values, but a lot of times people will use slope y-intercept method. After you've plotted the points, you're going to connect them. We are going to use a dashed line for the boundary line if we had a less than or a greater than symbol, because the points that would normally be on the line we're not allowed to include. We're going to make our boundary line a solid line if we have the inequality symbols greater than or equal to or less than or equal to. Now, what we're going to do is look at your boundary line, and we're going to shade above it if you have either of these symbols, or we're going to shade below it if you have a less than or equal to. Finally, we're going to check to see if you've represented the correct solution set by taking a point and testing it in the shaded region. We're going to take an ordered pair and we're going to substitute it back in the inequality. If the test point makes the inequality true, you shaded correctly. If the test point we picked makes the inequality false, we need to shade the other half of the plane. And finally, remember to label your graph with the original inequality. So let's look about graphing this. Our first graph has x is less than -2. Remember that when we have x equal to a number, that was a vertical line. So what we're going to do is first, when we graph the boundary line, we're going to pretend it's as if this said equals -2. So I recall that when I'm going to graph, very first thing I'm always going to do is label my axes. Y is my vertical axis, the long tail going down. And x equals -2 is a vertical line going through the x-axis at -2. So I go to -2 here. It's going to go through there, and I'm going to graph my line. But you need to wait and say, look at this symbol. This symbol is less than. It's not less than and equal to. So it's going to be all the numbers that are lower than the ones shown in this boundary line. So to show we can't graph anything on this boundary line, I am going to connect this with dashes. This is still dividing my coordinate plane, but any point that would fall on this boundary line would not be included in this inequality. And now I take a look, I said, if x is less than -2, where are all the numbers that would be less than -2? Would it be on the left side of this boundary line or the right side? If you're not sure, you can pick a test point. So say I pick a point here. You don't want to pick a point on the boundary line. Pick a point well into the shaded region. Say I pick a point here. This is my testing point. The coordinates of this point, 1, 2, 3, -4 and a +4. This is my testing point. So I'm going to go back to my original inequality, and I'm going to replace any of the variables with the value of my testing point. Since I only have x here, I look at my x value, -4. Is it true that -4 is less than -2? That is true, which means this is a true solution, which means all the other points that would make this true fall on the left side of the boundary line. So if you go to the boundary line and you just start drawing at a slant, you are going to cover the rest of this plane. And what that's telling somebody is that this shaded region, every single point in this region will make this inequality true. The last thing that we do is we're going to label this shaded part with your original inequality. So that's x is less than -2. And you have just graphed your first inequality. Well, let's take a look at this next one. A little bit more challenging because remember that we need to have this in y equals mx plus b form, and it's not. So we're going to get it into y equals mx plus b form by isolating y. I start by moving the 6x instead of a positive 6x. I'm going to have the opposite negative 6x. Whatever I do to one side, I do to the other side of the inequality. This is a zero pair. I have -2y is less than or equal to -6x plus 8. I'm almost there. Instead of multiplying by -2, we're going to divide by -2. Remember, every single term gets divided by -2. So I have y, and remember, when I divide by a negative, that means the inequality sign gets flipped. So y is greater than or equal to 3x minus 4. And you have a number of different ways that you could graph the boundary line. The easiest one here, I think, is the slope-intercept method. You could use table of values. You could also use the intercepts. I really wouldn't suggest that. So let's take a look at our table of values. Our slope, our m value, is 3. Remember, if we're going to use that to graph, we need to make this a fraction. So I put this 3 over 1. And since this is a positive in the x part, the y, this is going to go up 3. This 1 is showing my change in x, so it's going to go 1 to the right since it's positive. My b value is -4. And I'm ready to graph my boundary line. I take a look at my inequality symbol, and I see that there's an equal sign. And actually, I'm going to go to where I had simplified this, because that's going to help me with the shading. Since this has an equal sign, I know my boundary line will be a solid line, not a dashed one. All right, we're ready to graph. I'm going to label that y and x. Remember, the y-intercept shows us where to begin. Our b value shows us where to begin. So that's -4 on the y-axis. Our m value, our slope, shows us how to move. So we're going to move up 3, 1 to the right, put a dot. Move up 3, 1 to the right, put a dot. Move up 3, 1 to the right, put a dot. We're going to connect this, and we are allowed to connect it with a solid line because this was greater than or equal to. So we'll do that. Now we have to decide where to shade. Remember, this boundary line splits your plane into 2 parts. One part has all the solutions that make this inequality true, and the other part, no ordered pair here would make the inequality true. So let's see what we could do. There's 2 ways that we could approach this. One is, if y is greater than or equal to 3x minus 4, visualize somebody walking on this line. I call him my mountain man. If it's greater than, we're going to shade everything above that person, everything that would be above where he could wave his arms. If it's less than, we would shade below his feet. So this hiker, since this is greater than or equal to, we are going to shade above. So I'll start at the boundary line, and remember, let's just do this at a slant. And we're going to cover the entire section of the coordinate plane with those lines. Do not shade it. Do not color it in with your pen or pencil. You want to have just maybe 5 or 6 lines. You're going to see at the next lesson why that's so very important. Okay, but what if you said, I don't really know if I shaded correctly? Well, let's pick a test point. So I'm going to pick a test point well into the shaded region. Let me pick, let's see, this one. So here's my test point. My test point is 1, comma 3. Test point 1, comma 3. What we're going to do is go back to our original inequality to substitute it in, just in case we made a mistake when we were simplifying this. So I remind myself the x value is a 1, the y value is a 3. So I'm going to substitute it in here. This is 6 times 1 minus 2 times 3. Is that less than or equal to 8? Remember, if the testing point makes this true, then we know the testing point works, so everything on this side of the boundary line would work. If the testing point is not making this true, then that means it does not work, and everything on the other side of the boundary line should be shaded. Okay, so let's see. This is 6 minus 6 less than or equal to 8. Is it true that 0 is less than or equal to 8? Absolutely. So we know for sure that this side should have been shaded correctly. And finally, we need to write our original inequality somewhere in the shaded region. I'm just going to put it over here. 6x minus 2y is less than or equal to 8. And this is another SOS video.